My name is Advesh and I am from Vivekananda Education Society, Mumbai.
My name is Himanshu Jain. I am from Techno India Engineer Institute of Technology, Udaipur.
I'm Priya Valentina of Vienna Vignana Jyoti Institute of Engineering and Technology, Hyderabad. So, our project is about violent individual detection. With increasing crime rates nowadays, smart surveillance systems have become the need of the hour. We cannot depend on humans to constantly monitor because there is often a delay in reports. Innocent lives are lost and public property is damaged due to inefficient and slow response. Functionality of the automated smart surveillance systems of today can be extended to detect violence as well. Over the years, various computer vision techniques have been implemented to recognize various human actions like walking, sitting, eating, etc. Similarly, we can consider violent activity as a class of emotion recognition. To distinguish violent and non-violent videos, a proper data set is required to learn the behavior in various environments so that it can be used in real-time systems as well. Various models based on handcrafted features have been developed, but these suffer from being irrelevant to be used in real-time systems. Therefore, in this project, we consider a deep learning approach based on 3D CNN. 3D convolutional neural networks aims to extract features directly from the raw input by applying convolutions on the sequence of contiguous video frames. This functionality makes it suitable for violence recognition as well. So for our project, we have decided to use a pre-trained neural network, MobileNet, that has been trained on the ImageNet dataset in combination with LSTM neural network to detect violence in videos.
As my colleague Priya explained about the overall view of a system, I would like to continue with the methodology. The objective of our proposed work is to develop a practical system that can automatically monitor and detect public violence in the surveillance video and assist the authorities to spot this event and take the necessary measures. The computerized video surveillance system first learns the features from the model and then applies it to the LSTM system architecture. The system architecture is made up of four salient sections, namely dataset, data preparation, data learning model, video machine. The system is implemented on Google Colab and TensorFlow as in backend. Dataset. The real-life violence situation dataset has been used for our work. Data preparation. The raw data needs to be organized and managed accurately. It includes two submodels, namely data augmentation and data annotation. The system is using supervised learning technique, so annotation plays an important factor that labels the training dataset. A deep learning model. Deep learning based model technique, convolution neural network stack, is used to extract the features from the video frames of an input sequence in combination with LSTM, which is used to predict the nature of the video sequence. The prominent technique of transfer learning is being used in this model. Experimental setup. The experimental setup describes the flow chart that shows how the data flows when using the ImageNet model for transfer learning. We input and process a sequence of 20 labeled video frames in batches with the MobileNet model. The layer preceding to the final classification layer is selected and the transfer values are given as an input to LSTM neural network. The LSTM neural network is trained using the classes from the dataset, violence and non-violence. Based on the transfer values from the ImageNet model, the LSTM neural learns how to classify image taking into account 20 frames of the video. If any of them detect violence in the frame, the video will be classified as violent video. The violent video is then passed to the cascade classifier, which crops out the face of the person from a video frame. The captured person face is compared with the face data and the violent individual is recognized. Video machine. A video machine is an interface between a deep learning model and user. The system will take the input from the user and process it with the model. The system will return a message to an appropriate authority if any violent activities are detected as well as recognize the violent individual. Deep learning Keras library with TensorFlow backend is used to implement different ImageNet models. The training has been done with Google Colab GPU. We have reported the accuracy metrics of the training phase and observed that accuracy did not converge after 100 epochs, indicating that overfitting has occurred. Therefore, we have set the 100 epochs as the standard for our model. Feature extracted plays an important role in the prediction model. The extracted features are fed into LSTM-based neural network. Combining features extracted from the pre-trained model and NSTM, we acquire an architecture in which information from the preceding frame is preserved and recollected. Thus, a well-informed decision about each frame can be taken by the model and ultimately about the video. We were able to observe from the graph that MobileNet plus LSTM model overfits to some extent. Although the performance of the model is high, but it was observed that model was overfitting as there were inconsistency in the testing accuracy metrics to some extent over time. Finally, after analyzing the accuracy, we concluded that the features extracted from the MobileNet plus LSTM model seem to be more salient, and it can be attributed to the fact that MobileNet has a unique architecture that yields satisfactory results. Now, my colleague Himanshu Jain will be continuing with the conclusion.
Conclusion. In this paper, a new network architecture has been proposed for a violent interaction detection in a video, along with the aggressive individual identification. This paper highlights the facts that training a deep network from sketch network evokes overfitting issues. Therefore, an alternative strategy of transfer learning is adopted in combination with long short-term memory network that outperforms straightforward convolutional neural network. The accuracy also increases to a certain margin. The data set used for our work as well as steps involved in a data preprocessing has been explained in detail. The system provide a simple graphical user interface of highlighting border of different colors to interact with the deep learning model. The journey does not end here. How we have the plan to create a database where the timestamp of violence and screenshots during surveillance can be stored, which can be beneficial for future use to higher authorities.
Finally, I would like to thank Anugrah Srivastava sir for guiding us excellently throughout this internship. We are also thankful to the Bennett University and the Leading India AI for providing us such a great opportunity to work with them throughout this summer internship.
I'd like to thank our mentor, Anugrah Srivastava sir, for being with us throughout the completion of this project. He's provided us with some great insights. And I'd like to also thank the Bennett University for providing us with this internship, collaboration with the Leading India AI.